Welcome back to the shop, everybody. I'm running production on the Haas milling machine, and I thought I'd show you guys the job and the part and just kind of talk through it. And actually, let me just start my watch here. Okay. This here is a part that I developed in 2018 for bike frame builders. It's the Braze clamp body. I put a screw with this, and you can put it around tubes on your bike frame and clamp it in. You can hold braze-ons and different things for your bike. Anyway, make these out of 6061 aluminum. So these here are blanks that come off of the auto bandsaw that I've showed in the shop tour video. Compressed air really screws with the microphone, kind of auto adjusts the level. So anyway, you can probably hear me again. What we have on this setup here is the Haas VF4 2019. This here is a 210 style rotary, HRC 210. It's the fast one. They don't make this one anymore, but it's got a roller cam. And the Rotovise, which I really love, works really well for this because I'm doing production, so I can hold 4 parts at once with the grip jaws, and then I can clock at 90 degrees in the machine, and I can do this cross hole that's M8 drilled and tapped and back chamfered. I use a back chamfer mill. And so anyway, when it comes time to advance the parts at the end of the 18-minute cycle, not super optimized, but not terrible. Anyway, I gotta change these parts out manually. And I make maybe 100 of these a year, something like that, depending on sales. And if I made a whole lot more, then I would probably develop a different process. Actually, this is a new process. For years, I used to use a different process, and it yielded more parts per cycle. I get 8 parts out instead of 4, but the operator, as an operator, it was just more tedious. I had a fixture pallet like this, and then a 4th axis tombstone, and it's just annoying. I just don't like these little fixture clamps from an operator perspective. They're annoying. But anyway, so okay, I'm changing the parts out here. And I use this stop lock ruler that I get from MSC Direct for 30 bucks. Comes with little set screws that are 1/4 28. I throw those in the trash, and I use these as a McMaster car part. It's just a knurled thumb screw that's 1/4 28. And then you set this with digital calipers to whatever your length is. So in this case, the jaws are 3-inch. The part needs to be centered. The part is bandsawed to 4.34 inches. So you take 4.34 minus 3, divide by 2. Digital caliper sets this distance, and now you set your part in the right position. Work stops are cool, but they don't always work when you have a bunch of vices or you're doing multi-axis or whatever. I don't use work stops very much at all, actually. In the 3-axis vices, when I need a work stop, I just probe it most of the time. And then anytime that I'm setting rough position of raw stock or something, I just use these most of the time. You could 3D print a custom stop. I don't usually bother, but you could. And then also, I don't know if you noticed, but while I was rotating that, I was locking. So if I press the jog A axis, it unlocks the pneumatic brake on that rotary. And then if I hit the X axis, it locks it again. So if I'm torquing on here, I'm not putting all that load into the roller cam, which is somewhat delicate. And anyway, but this is a common workflow for me. Is rough stock on the Rotovise here gets grabbed with these serrated grip jaws, and I can do multiple indexes and orientations. Plus, it just holds 4 pieces in a very small footprint with good rigidity and good part access. I'm a huge fan of if you do work anything like what I do, like blocky parts from bar stock, and you're machining in volumes of 16 to 200 piece runs or something in parts that are in the right size range. This is fantastic. I would say probably like 60% of my mill parts or more start on this Pierson Rotovise. I just load bandsawed material into these jaws, and then I finish it most of the time over here in these 6x20 inch dual station orange vices. So in the case of this one, I can't really grab this with normal hard jaws, so I'm using these soft jaws that I just cut the other day, and so they just have a pocket to hold the part. And I like to wash the parts a little bit before I send them to anodize. This here is a chunk of carbide from an end mill that just blew up. I did a video about shrink fit tool changing out, so just found the part of the end mill that blew up. Anyway, I'm gonna set these parts in here, and I just want to make sure there's no chips. And you can, this particular part, you can really feel it. If you do this, you can feel if it's rocking on a chip. And in fact, in one of the first runs of this, I clamped the chip right there. I can see the indentation, and I'm sure there's a matching indentation in the part, so just trying to avoid that. I would love to get a spindle gripper set up and a pair of pneumatic vices and automate parts like this, but I just do such a wide variety of parts in relatively lower volumes that I can do that, but the juice is like maybe worth the squeeze. It's kind of borderline, you know, whereas this is a pretty good workflow. I'm getting 4 parts out per cycle. The soft jaws cost some money, but it's a relatively low dollar investment. Because these parts are kind of flexible and kind of dainty, I'm using the torque wrench. In this case, I set it to 20 foot-pounds was my first guess, and it's pretty good. It's working just fine. The dimensions and stuff on this are really not that critical. In the machining world, these are pretty loose tolerance, but I want the Op2, want these backside chamfers to look nice and consistent. So if it really squishes the part, or if you're really out of position, you'll see that this little chamfer is way heavy on one side and light on another. And so I'm looking for, that's one of the big tells if something is totally distorted or totally wrong. And so these are coming out looking good. I'm pretty happy at 20 foot-pounds, and I haven't lost a part. And you'll notice, you know, this is a common workflow, is Op1, you grab it low, so this is 3/4 stock. I'm grabbing up to 100,000ths of an inch, almost 3 millimeters up the 19 millimeter thick stock. And I'm, you know, profiling the whole part, and then I flip it over and I just plow off the carrier stock. But you'll notice I lopped off these corners, and I put a big circle in the middle. And the reason for that is just that if I had left the whole rectangular profile of carrier stock, then what would happen is when my face mill came in to get rid of it, if I just wanted to run the face mill over it, you would get these like little flaps and extensions of material that could just destroy the inserts on your face mill, or they can vibrate and chatter and make issues. And so before you would face mill it, you would actually come in with an end mill and you'd remove the material. But because it's kind of a dainty part and you don't have the best hold on it, and because an end mill has a helix that wants to lift the part, then you have all this cycle time burned, kind of gingerly chipping away at that. And I realized that I could just knock off this carrier stock a lot better and faster on Op1 after I had cut the geometry. I could come in and I could knock off these corners and punch out the circle so that there would be less material to remove tediously in this second operation. And that's been working pretty good for me. Although I slice, like this part right here is just a bridge because the part, you know, sits below it. Part sits like that. And anyway, I just sliced that with a little 1/4 inch end mill. I'm slotting it out, and it leaves little chunks like this. And one of those was sitting right here in my end mill that does some finishing. Came around and it hit that, and it just nuked my end mill. So I don't know if that was worth 50 bucks to make that little mistake. I should probably chop that into smaller pieces rather than those bigger pieces. But anyway, that's just an overview of a common setup for me. Is like multi-axis, Op1, bandsawed, rough stock, very little prep work that goes into making these blanks, and then it loads over here into the operation 2. I trim that off, and these are done. They're ready to be cleaned, which is a process I need to optimize with a dishwasher or something. Sent to anodize and put into inventory. So it's relatively low amount of screwing around to get nice parts through the machine, and I think it's a pretty good process. But thanks for hanging out. Just wanted to share that.